7.2, Part 2. Writing exponential growth or decay functions given 2 points. So, ladies and gentlemen, if I give you 2 coordinates, let's say I gave you number 13 from our homework, which is 0, 3, and another point, 3, 375. Let me ask you this. Just by looking at your coordinates, will this be an exponential growth or decay function?
Growth.
Definitely growth, right? 0, 3 is right here. And if you go to the coordinate 1, 2, 3, and 375, it's way up there, right? So that's a crazy growth. Yay? So we know it's a growth function. We need to write the exponential growth function. Now, in order to write an exponential growth function, you need to know what the form is. Kind of like if I said write an equation in slope-intercept form, you need to know what y equals mx plus b means. In this case, an exponential growth function, what does an exponential growth or decay function, for that matter, look like? Y equals a times your base to the x power. That's ignoring h and k, of course, but that's what all exponential growth or decay functions look like. If your b value is greater than 1, it's a growth function. If your b value is less than 1, it's a decay function. You guys know that, right? Okay, so what are we going to do? Well, let's take this first coordinate and let's label it x and y, because that's what it is after all. And what I'm going to do is plug in this first coordinate, and I'll be able to identify the a value that I need. Okay, so before I even start plugging in, I need 2 things to write this equation. I need an a value and a b value. Okay, by plugging in my first coordinate, the x right there and the y right there, I will be able to find out the a value. Check it out. This only works because your x is 0 on the first coordinate. So your y is 3, so it's going to read 3 equals a times b to the power of x, which is 0. Now, it's beautiful when you have the power of 0, because the power of 0 is what? 1. Anything to the power of 0 is 1. So this b to the 0, that cancels out. That's really 1. So your new equation is 3 equals a times 1, which means that 3 equals what? 3 equals a. In other words, a equals 3. So you know that 3 equals a. You know that a equals 3. And ladies and gentlemen, that's half of what you need. You already know that this a right here is going to be 3. All we need is the b now. So how do you think we're going to find b? Plug in the a and plug in again an x and a y. Now it would be ridiculous to plug in the same point, because then you're just dealing with 1 point. But if you plug in the other point, then you're really dealing with the whole exponential growth function. So what I want to do is take that a value, and I want to take this x, the y, and the a, which is 3 that we just found, and I'm going to plug it all into this so I could solve for b. So once again, instead of y, it's going to be 375 equals my a value. We know that a value is 3. And now times my b value to the x power. So times my b value to the x power. What's the x power? 3. So I really have 375 equals 3b to the 3rd. Okay? So now let's solve it. How do we solve it? Well, let's get rid of the 3 in front by dividing by 3. That'll cancel it out. Divide by 3. You're going to end up with your new equation that says 125 equals b to the 3rd power. How do we get rid of the power of 3? The cube root. Exactly, the cube root. What you do to one side, you do to the other side. Cube root. So what is the cube root of 125? 5. So you have 5 equals b. Ladies and gentlemen, this is not your answer yet. They're asking for the equation, the exponential growth equation. So we're going to say y equals a times b to the x power. So our final answer will be y equals a times b, might as well put that in parentheses to keep it clean, to the x power. This is your exponential growth function that actually passes through the above coordinates 0, 3, and 3 375. Let's jump to the second part of our homework assignment and work on those that they give us 2 points and they ask us to write the equation. So that would be on the second half down here, and I don't know, pick one.
Number 13?
We just did 13.
Or 19.
19? 16? Look at it. 16 has fractions and decimals. That one sounds fun, right? Now, you're probably thinking that it's hard. It's not. Check it out. What do we want our equation to look like? You don't want it to look like y equals mx plus b, because that's a linear function, right? You want it to look like y equals a times b to the x power. Again, y still ugly, equals a times b to the x power. That's what we want it to look like. So what do we start doing? See, this is super easy because the x value is 0. If you plug in 0 right there, this cancels out because anything to the 0 power is 1, which ultimately gives you your a value because the y is going to be 1/2, which means a is going to be 1/2. So let's just show our work anyway. Plug in x and y. So you're going to have 1/2 instead of y equals a, which we don't know, times b, which we don't know, to the x power, which is to the 0 power. Now, the beauty about this is that you have it to the 0 power, which you know is 1. So you really have 1/2 equals a times 1, which just means that a equals 1/2. All right? A equals 1/2. And that is half of what you need. In order for you to write your equation in exponential growth or decay form, you need your a value, which we already found is 1/2, and then you need your b value, which tells you whether it grows or decays. Now, you could just tell me right now, if your input was 0 and your output's 1/2, and then you went to your input 1, and then your input 2, and you got out a 40.5, is that growing or decaying? That's growing. So you already know it's going to be a growth function. You already know your b value is going to be greater than 1. You don't even need to go through that thought process, though. Let's just jump to finding our actual b. How do you do that? We're going to use the other coordinate. This is your x value, this is your y value, and we're going to plug in our x right there on the exponent for x. We're going to plug in the 40.5 for y, and then we're going to solve for our b value because we're already going to plug in the a value of 1/2 right there also. So we're going to take our x, our y, and our a and plug them all in here, here, and there, and then solve. So we're going to have a new equation that says 40.5 equals a, the a value is 1/2, times b, the b value we don't know yet, to the power of x, and in this case, it's the power of 2. Okay? So let's start solving for b. What do I get rid of first? The 1/2. You could either divide by half, which is really going to be multiplying by the reciprocal of half, or you could simply say, I want to multiply by 2, that'll cancel it out. What I do to one side, I do to the other side. So 40.5 times 2 is 81, correct? Equals b squared. I need to get rid of the square. What do? Square root, b equals 9. So we have our a value of 1/2, our b value of 9. Now we could take that 1/2 and put it right there, the 9 and put it right there. So our final answer is y equals 1/2 times 9 to the x power. And this is your exponential growth function that actually passes through the above 2 coordinates. What do you think? Practice makes perfect. Which other one would you guys like to see? 18, 19, 18. Why not? 18. Okay, so this is your x, this is your y. You're going to start by saying y equals a times the base to the x power. Y, -6, equals, let me actually write it, I don't want to be lazy here. Y equals a times the base to the x power. We're going to plug in the y value of -6 equals the a value. We don't know what it is, and we don't know what the b value is either, but we know that the x value that we're plugging in the exponent is 0, which we know makes the b value a 1 right now, because b to the 0 cancels out, it becomes a 1. So there is no more b. So what you really have is -6 equals a, which means a equals -6, and that's half of what you need. The only other thing you need is the b value. So what are we going to do now? We're going to take the a value of 6. So let me rewrite this guy right here. We have y equals a parenthesis b to the x. Let me take that a value of -6 and put it right there in place of the a. Let me take the b value, which I don't know, and leave it b. And let me take the y and the x from up here, x and y, and plug it in. So I'm going to have a -1,536 on the left side for y. Now I'm going to have the power of -4 on the exponent of the base b. What do we do from there? You want to start solving for b. So let's get rid of the get rid of the -6 that's in front, the multiplication of -6, by dividing both sides by -6. Now, if you take a calculator and divide 1,536 divided by -6, we're going to get a positive what? So you get 256, and at this point, that -4 is throwing me off, yeah? So what you could do is change it to a +4, as long as you change the other side by doing the reciprocal. Does that make sense? So you could make this a 1 over 256 equals b to the +4. Is that? So if you take the fourth root of b to the 4th, you're going to get b on the right. And if you take the fourth root of 1 over 256, so with the calculator, when you split the fourth root of 1 is still 1, and the fourth root of 256 on a calculator is 4, because 4 times 4 times 4 is 256. At this point, your final answer will be y equals a, which is -6, times parentheses the base 1/4 that we found to the x power. So that's the answer. Y equals -6 times base 1/4 to the x power. Now maybe it got a little funky right here, right? With the 256 equals b to the -4. Is that where it got funky? People got confused right there. So check this out. What if I rewrote that and took an alternate route? There's many roads to the same place. 256 equals b to the -4 power. Okay, so what if I did the power of -1 right here to make it a b to the +4? Would that make it a little better? And if you did to the -1 over here, maybe that explains it a little better at least. Because that way, on the right side, you'll have b to the +4, right? And on the left side, you're not going to have 256 to the -1 power. That's really going to be 1 over 256, because negative exponents, you move them to the other side and they become positive. Does that make it a little more understandable? Yeah? Okay, and now you're going to apply, again, the fourth root. The fourth root here, the fourth root up here, the fourth root down here when you split it. And you'll get b equals, the fourth root of 1 is still 1. 1 times 1 times 1 times 1 is 1. And 256, the answer is 4, because 4 times itself 4 times. 4 times 4 is 16, times 4 is 64, times 4 is, I don't know. But the bottom line, it does get you 256. If you did it on a calculator, the fourth root of 256 is 4. I hope that kind of clarified it a little more to find b. So the only way to make this easier is to practice, and you have a whole page of practice. So don't forget to study graphing, exponential growth and decay, and studying this whole worksheet right here for the Quiz Friday.